So I'll just record with both, and that'll be that. That's recording. Yep. Okay, good. All right.
And I can record my sound. Do you want me to record my sound separately and then I can send you the sound file?
I mean, I think
Or it's been fine up until now. It's not like we're doing it.
Yeah. No, I think it's fine. I'm not gonna do any broadcasting.
Yeah.
Because the one thing I didn't like from our last recording was when you were talking, it was focused on me the whole time. You know, like that for a large portion of it towards the end. If you look at the recording that I posted that you sent me, it was my face when you were talking. And I was like, man, I wish it would have switched over to you when you were talking. And then maybe back to me when I was
that's
talking.
how it's supposed to be, yeah. That's how it's supposed to be. Oh, that's a mess.
Yeah, like towards the end of that first conversation we had, it was showing me more. And I was like, you know, and I'm like all zoomed in looking. I could see you, but it was my face recorded. So that was odd.
So we'll just I will just go for it, hey?
Yeah.
So Harry, you've been building this summer.
Yeah.
And so have I. Should we just bring like a summary of experience?
Yeah, absolutely.
You go for it first.
Sure. So I've been having workshops and teaching people to build with my building system that I came up with. And it took a long time for me to come up with it, especially the foundation system. And that's, I think, what I'm most proud of is the foundation system. So most recently, the last workshop just ended last week. We had 4 people come to the workshop. And for the first time, we did a double dome system where we inflated one airform, we sprayed it with cement, and then we put a second airform over that one. We sprayed that one with cement, and then we filled the cavity with Aircrete. So I like this method because when we look at the way Hadar teaches, which is really good when it comes to layering fabric on the inside and outside. As he said in his TED Talks, this is like gypsum board. Gypsum board is very weak until you put paper on the 2 sides and then it gets strength. So the way they do their system is after the dome is built and shaved and everything, they wrap it with the fabric and stucco it. But the difficult part is doing the inside of the dome, you know, being able to wrap it and apply. And I haven't experienced it myself, but I know some other people that have done it and said that's the more difficult part is applying it on the inside. Now,
I just want to correct you, Harry. Hajar's method only puts fabric on the outside and only puts fabric on the bottom parts of the dome when it still curves like this. As soon as the dome tips over this part, all the bricks work on compression. So no fabric is needed at all.
So there's none on the inside.
And there is none as soon as you go past this part of the half.
Yeah, the equator.
There's no fabric at all. It's just there so the bricks don't flop.
Okay, so even more reason why I prefer the way I came up with it, because my fear is if you're building anywhere where there's trees and the tree comes down, the Aircrete, you know, will only have but so much strength. And not having reinforcement on there is, you know, but again, I'm thinking about American building codes and complying with that and then maximum strength. So with the method I originally did back in New York years ago, I did the first airform, covered it with cement, and then I put a second airform over to fill that with Aircrete. Now that experiment didn't fully work because the pump I was using basically exploded. I made my own little plastic cement pump bomb because it clogged up. And so anyway, so now with this system, I've inflated the airform. I've also made a fiberglass mesh as my reinforcing fabric that goes over that. And then all of that gets cemented. So the entire first layer is reinforced with fiberglass mesh. And then the second airform goes over with a second fiberglass mesh. And so now I have two shells that are reinforced with mesh on both sides.
What's the gap between the first and the second?
The gap that I've done here is 6 inches. So that would be, the one that I built was a 10-foot and an 11-foot airform, giving me a 6-inch. So if I were going to build like in Alaska or somewhere, in the northern parts of the country, I would go with a 10-foot and a 12-foot, giving me a 12-inch cavity in the middle. And so I could fill that with Aircrete to be really super insulated. Now,
I'd just like to pause you here, just to explain to maybe people that haven't built, any natural buildings. If you were to do let's say, generally dome Gaia bricks, they're 10 centimeters thick. Pouring Aircrete, anything higher than 4 inches makes it flop. Generally, I haven't cracked anything. So if you're trying to do what Harry's explaining with bricks and 12 inches thick, that's 3 layers of these bricks. First of all, it's probably 1,000 bricks on a 12-foot diameter dome. So it's a lot of bricks and it's going to be a lot of time. What Harry is talking about is basically the insulation is being poured between the 2 layers in one go. So just elaborate, because that's an extreme. What you're talking about is a 90% time saver. Correct?
No, it is, because the first layer is only being, so to explain it from the beginning, we make an airform, and I'll use the one we just built. I have a 10-foot diameter airform. We inflate that airform, and over that airform is a fiberglass mesh, which is the same as mosquito netting. It's the same material. It's made of fiberglass. And I've taken that material and sewed the gore pattern, the triangular shapes, into a dome form. So it's just like the hat has a gore pattern with these caps. So I've made that fiberglass mesh to slip over the airform like a hat does. And I purposely make it a little bit smaller than the airform so that when the airform is filled with air, the pressure will push against the fabric mesh. And there's zero chance of you popping your airform from over pressurizing it. This mesh holds everything nice and tight together, and the mesh being flat against the airform. Now the airform is a smooth surface, and so the mesh.
Can the 2 forms be cut out simultaneously? Let's say if you have to make 10 of these domes or 5 of these domes, could you put your template over the fiberglass mesh and over the Tyvek airform fabric and cut one go?
That's correct.
With a roller cutter, correct?
No, I use just a regular straight blade. I have tried the roller color, like a pizza color cutter, but I find it best just to use a regular razor blade, with a handle. And so yeah, you can absolutely do that. So as an example, like the 16-foot domes, when I build them, they take about 14 gores. So we'll take 14 sheets of fabric to the proper length, and then you can also take 14 sheets of fiberglass mesh. Put your wood template on top and cut through all of them at once, so they're all perfectly cut and all symmetrical, and there's no mistakes. You're not doing one at a time. That would be insanity. So you do them all at once, real easy to cut through all the materials. And after we cut everything, we sew it up. We don't sew the Tyvek and mosquito netting together. We want those 2 separate, because the Tyvek will be removed once all the spraying's been completed. So we put that airfoam on there. Now it's holding the pressure and is also acting as grip for the cement. It gives the cement something to grab onto, because the tie back is so slick, it's so smooth. Now the
So what
benefit of the
happened?
tie.
Just sorry, I'm going to be just not
No, that's
interrupting, but
good.
just a clarification, because I'm trying to hear as maybe an experienced builder who is interested in your method. What happened before when you didn't use the mesh? If you just use the tie back?
When I just used a tie back, the very first dome I built in 2019, the winter in December, we built it. I had to spray very, very light coating of cement on it so that the cement would stick to it. And then the next layers I could build up, make them thicker and thicker. But if you just try and go too heavy, it'll just slide off the airfoam, especially on the vertical wall. Once you reach the equator, it holds much better. But on the vertical walls, it slides off unless you do a very light coating first. So to avoid that,
takes time.
yeah, it takes more time. So by having the mesh on there, it's, for me, it's the first layer of reinforcement, your very inner layer, so that you have protection on the inside throughout the entire dome of reinforcement. And then after we spray layer upon layer on, after like the first 2 layers, then you could start spraying on much heavier, because all the cement is very rough and it gives more cement something to grab onto even more. So,
and what, Harry, how much can you spray at the first application if you are using the mesh? Are you talking about a 1/2 inch or a little bit less?
usually I try to go for like an 1/8 inch to a 1/4 inch. You know, it's hard to gauge when you're spraying, but I go for 1/8 to a 1/4 inch. And then like about 2 or 3 hours later, depending on the cement mix, I'll do the next layer. And so what I'm going for when I'm using cement sand mix and latex is I'm going for a 1/2 inch to 1 inch thick. Really, a 1/2 inch is more than enough.
That's the next application. That's the next coat already.
Right, after you get past that first 1/4 inch, then what I like to do is put another reinforcing layer. And usually I'll move on to either basalt mesh or a stucco wire mesh. A stucco wire mesh looks like chicken wire. So you could call it chicken wire, but it's a thicker gauge wire. And it's galvanized also, so it doesn't rust. And it's stucco wire, so it's meant to be sprayed with cement.
So here is a question for you, Harry. To speed up the whole process, could a chicken wire be cut again in that hat? Those let's call them orange slices.
Yeah.
That make up the sphere. Yeah, the half a sphere. Could that be cut 1 inch wide, bigger on all edges than the same shape as your mesh, as your first mesh, and the same as your tie-back mesh, and stitch together with possibly wire and put on or not? It's not going to work.
Now that is what.
Or do you find it's better to wrap as you go and just wrap and then, you know?
Well, it depends on the width of the wire. The wire mesh comes in a roll, usually 100 to 150 feet long, and it can come anywhere from 3 feet to 4 feet in width. So my small dome, I did do that. I cut the mesh. Actually, I didn't cut it. I folded the edges to make the gore shape, or as you call it, the orange peel shape. I folded it in and I left the overlap, and then I did wire tie it. I used the wire ties and basically made one monolithic mesh all the way around. And that's what I really like. I like things to be monolithic. That just means everything's poured at once. Their mesh covers everything at once. And for me, that's maximum strength you get. And so, but now with larger domes, like my 16-footer, I just use a 3 foot wide piece and just go over. So what I'll do is, because the method I'm using is a low pressure airform, means all I need is a leaf blower or like a bouncy house blower. So very minimum equipment. And so when I inflate it, if I try to spray too much cement on it, the airform would collapse. So what I always do is the first day, we build up the base layer. So from the ring beam up to about 4 to 5 feet. And so we'll spray that lightly. Once we have a 1/4 inch, I'll take the the mesh, either basalt mesh or stucco wire, and I'll go around the dome, around the circumference, and then I'll spray that so that that wire mesh is embedded in cement. Now I'm not worried about my airfoam collapsing from weight, and I've got my base structure around the dome airfoam, my shell.
And that takes most of the weight. So it's important for you to get the base because that's your support. Everything else, it gets much lighter at the equator, as you call it, correct?
Right, correct. And I had the hard lessons when I first did it. I've made plenty of mistakes, which are all learning lessons. You know, we learn a lot from our mistakes. And I'm more than happy to make the mistakes and spend the money so you don't have to. But I have made that mistake before, which is how I've come to this. And when I teach the workshops, I tell everybody the mistakes I've made and what to avoid and how to get it right the first time. So
it's brilliant.
Don't make mistakes.
Just to chime in there, I had a YouTube comment lately on one of my things when I explained one of my mistakes. And somebody said, yeah, that's what sucks about all you people. You don't even figure out the method yourself and you're selling the online course. And I'm like, first of all, this video is 2 years ago. I have long solved the issue. And thanks God I did, because I can share it with you guys so you don't make the same mistakes.
Yeah. Someone has to make the mistakes.
Yeah, this is what brings, I think I've made over $50,000 worth of mistakes, which is stupid stuff.
But you've
like
learned.
Just to put in one of these, when I made this pool wetland, okay, here's a really good one. I bought a secondhand banner. You get those billboard banners on the highway, on a freeway, and you can get those secondhand very cheap, almost free. So what choices do we have? We either have EPDM liner, and you know the cost of that. That's what earthships use. But it's a goddamn wetland where gray water goes, or pool. You know what I mean? It's like it's not the water I'm going to drink. Why do I need to use expensive EPDM liner if I can get the billboard, literally a huge billboard? So I get this billboard for like $20, $30. So you obviously want to check for holes. So I lined the whole wetland, and it's a long one. It was about 15 meters, so 45 feet long by about 6 feet, 7 feet wide. It's that one next to the pool, the curvy one. And the first thing would come to mind is you fill it with water to see if, it slowly goes away. And then you find the holes, or at the level it drops, that's when you know where the holes are. But now what I did was I filled it up with water, and all that complex pipes for that wetland, which is basically 2 drain-X pipes going to two round white 2-inch pipes, going to one round 2-inch pipe, and that goes to a pump. And that one pump just pulls from all of that system. And I put all these pipes together in this floating water. And then I started filling with gravel. And man, it was the most expensive mistake in my life, because it goes like this as you drop the gravel. Then the connections start to come apart, and there's so many connections because this thing is so long and there's all these joints. And now we're filled up with a whole truck of gravel, a big truck of gravel. Okay, and maybe like it's huge. It's like probably weighs like 50 of your cars. and then our joints will come apart. So when my pump starts sucking, it just gets jammed with gravel. And I had to undig the whole thing and find all these joints. And now you can't pull back those pipes. I'll share a screen as you talk. I'll share just that picture just now. So the trick is, once you've tested your water, you have to, for any leakages, you drain that water. And if the water is scarce, you put it in a tank, but you drain it all. And then you put all those pipes dry, and you fill up with gravel slowly, dry. Once it's all set, and then you fill more gravel, and then you put your water back. And that was the most expensive mistake I did, because it took us 2.5 weeks fixing the system to trying to undig this gravel. It was a mess. I'll share the picture as you talk, but carry on.
Yeah. So once we have the first 1/4 inch coating on, and we put another basalt mesh or stucco wire mesh, we just embed that all in cement, And then we do the same thing with both dome shells. So now we have two reinforced dome shells made of concrete, a 1/2 inch to 1 inch thick. And so we have a lot of strength. Now it's just about insulating. So from the top, we make a hole. I stick a tube in, a hose, and we fill that cavity with Aircrete. So I'm in the middle of that process now. And guess what? I've made a mistake. We've had an accident, and this is one that I will definitely avoid in the future. The first airform had an area where usually when I make the domes, I don't spray where the door is going to be very much. I do a very thin coat because I know I'm going to cut through there. You know, so I'm making one solid dome, but where I know the door is going to be, I spray very thinly. So what happened is when I started filling with Aircrete, it pushed the thin part and the Aircrete was leaking into the dome. So here I think I'm filling the cavity. Meanwhile, I'm filling the floor. So I do have the walls filled probably about 4 or 5 feet tall, but I have about 12
4 or
inches
5
of
feet
Aircrete.
tall.
Well, on the outside where it's supposed to be, on the 6-inch cavity.
Okay.
But on the inside, about 12 inches got filled with Aircrete. So it leaked into the inside. The only saving grace is that it's Aircrete and I can easily chip it away and remove it. So that's the one thing that saved me as far, because had that been just concrete, it would have been just over. I would have had a really short dome. But the other thing I really like is this is the first workshop that I chose to teach how to use a stucco sprayer to do my method, because a lot of people are afraid or turned off to my method when they see me using a $20,000 shotcrete machine. I purchased the machine for myself because we had a budget and we had multiple large domes to build. So to make my life easier, I said, I'll invest in this machine. So there are a lot of people who do have some finances, like they're selling their house in the city and they have more than enough to afford one of these low cost homes. You know, from what I'm building, it's about 2,100 square feet. Will only cost about 30,000 in materials. That's mainly cement to build the entire thing, opposed to like a stick frame house. It'd be 30,000 just for a foundation. In New York, it's like 100,000 just for a foundation. It's insanity. So there's a balance. But so what I've done now is we have this stucco sprayer that you can purchase online for like 50 something bucks. And the only difference is you have to constantly fill the stucco sprayer. You have to scoop or pour your cement mix into the stucco sprayer, and you spray. As you spray, you know, that stucco sprayer empties the little hopper, and then you fill with more. This is how we built this dome, and I really enjoyed it because I hadn't done that since New York. I did that in New York, I think in 2015 or 2017, I forget exactly. That's how I built my first dome, was using a stucco sprayer, and it worked great. So when we finish this dome, I'll come out with the video, I'll show the workshop, and you'll see how we use very simple tools, just one air compressor, a stucco sprayer, a double paddle mortar mixer, and that was it, you know. And then my ingredients are key now. And I'm going to start offering this soon. I'm just waiting for my 1 gallon containers to come. I have a thickening agent and I have an air entrainment. Now the air entrainment you can get at your local masonry place. It's called air entrainment, and it's a liquid that you put in your cement mix, your cement slurry, that helps to entrain air in it. Now what I found.
Why does one need that?
Yeah, it makes your Aircrete like come out like chocolate mousse every time. You get the perfect consistency Aircrete. Now I didn't discover this. My buddy Gary in West Virginia, he did a lot of experiments and he discovered it, and he told me about it, and I said, this is great. When I first used it, it just really makes it come out like perfect looking.
And just okay, just folks, just want to chime in there. For those of you who have never made Aircrete, it sounds so easy when you see it on the movies. Let me tell you, I'm a building instructor. For 1 week of my own workshop, where I invited people from all over the world, we were getting Aircrete right. Because it's all good if you're in America and they tell you, use this soap with this much this and this much that. And it still depends on your cement, it depends on your weather, depends on your water, as Harry has discovered, too much acidity or alkalinity, and many, many factors. So what seems like an easy job, it took us a week because our Aircrete just kept on flopping. Harry's talking about this mousse. You need to get the Aircrete to, well, when we make bricks, at least to be 4-inch thick. So that's about this high. You pour it and it just drops. All the bubbles collapse. So it took us a week long just to get the mix right. And we played with glycerine and we played with 6 different soaps that we were trying from different shops. And then once we got it right, we said, okay, that's the soap. And then the compressor was not strong enough. I had a small compressor. I didn't know. You need to have a big compressor that pushes out how many cubic feet or something?
You want to have, really what you want to have is a big tank on your compressor. So even if you have a small compressor and you have tanks, like I've done this before in New York, I had multiple tanks I connected. So I had one small 5-gallon tank compressor fill 3 30-gallon tanks. So what you need is air volume so that you can consistently make Aircrete. Because if you have a small compressor, the air volume runs low and now your density of your foam changes. So this is why, like I have a Harbor Freight air compressor, it's gas powered, and it's a 18 cubic feet a minute compressor or second. Well, it's a minute.
How many cubic feet?
18 cubic feet. I think it's 18 cubic feet a minute. Yeah, a minute.
Yeah.
Every minute you get 18 cubic feet of air at 180 PSI. But wow, it has a 30-gallon tank. And so all you have to do, you don't have to buy this compressor. All you have to do is stop more often and check your pressure. If you have a small compressor, that's really all you have to do. Now, I want to give everybody a major tip here on making Aircrete. Everybody write this one down, okay? Number 1, for making good Aircrete, you need good water. And it's not alkalinity, it's hardness. Hard water will not make soap bubbles. So if you're living in a house and you don't ever get bubbles, you can't make foam, it's because your water is hard. So Aircrete relies on your bubbles. So you have to have soft water. Now, Alosha has on his BioVeda site, he has a program on water and making a filter from biochar. Now, this is key. All you have to do if you have hard water is run it through a biochar filter. It has to be large enough to filter the water. So my intent is to make what Alosha did in Africa, a 55-gallon drum. I'm going to fill a 55-gallon drum with biochar. And biochar you can simply make. Alosha has a whole program on how to do it. That's one of the main reasons I signed up with his program, because I was very interested in the water. So I say you get make yourself a water filter. Best just to make one yourself. With biochar, it has to be large enough so that the water you put in at the end comes out soft, because it's all of these particles and, there's all type of particles and that makes water hard. So that's the number 1 key thing to good air.
What do you mean by hard water?
Hard water means like there's minerals in the water that don't allow your water to make bubbles. And usually like, if you have hard water, you'll get like soapy walls on the shower and like your sink, you'll see kettle. A line there. That's because of hard water. Now you can get a hard water tester. I have these things listed on my Amazon link. So if you go to any of my videos in the description box, it takes you to my Amazon link, and I have different hard water tester. Now it's not alkaline tester. You're not testing for the alkalinity. Now, ideally, good alkaline water will help you some, But what's most important is the hardness. So you get a hard water tester, and there'll be a little color diagram. You take a tab, you stick it in the water, and you compare it to the bottle will tell you the different colors. And you want to look for the first 50 parts per million or less is what you want. And you'll see that on the bottle. So that's the
It's very
most important thing.
Yeah, it's very important what Harry is saying, because making Aircrete makes my hair go gray. In fact, when I go to a workshop now, like I'm going to Brazil now, I have asked our host to buy Aircrete bricks. It's called gas beton, or they have different names with foam crete, whatever. But it's professionally made Aircrete, because it is such a science. What Harry is talking about, you really gotta like figure the stuff out to make Aircrete that stays up. So I prefer now, for the time's sake, not to make our bricks at a workshop, because obviously you can't do Harry's method like with what I'm talking about. But if you're doing a brick method, I just prefer to buy bricks by professionally made company. It's still a hell of a lot cheaper than other bricks, like the clay ones. Harry, what's your opinion on purchasing Aircrete bricks versus making your own cost-wise?
I found that depending on where you are, like in this country, there's only, as far as I know, one plant in Florida that makes bricks. And I do know someone who made a dome using those autoclaved Aircrete bricks. And indeed, this is a system where they make a type of what's called autoclaved Aircrete. They put it in a steam chamber under steam and pressure, and they don't make foam like we do to make Aircrete. They add an aluminum silicate, and that creates the bubbles in the Aircrete bricks. And they're lightweight and very strong. Well, they're just as strong as the bricks you can make. But if you're paying,
but they're a bit stronger, correct? They are a bit stronger than
they're a bit stronger. But you're paying for that shipping. You're paying for the bricks and the shipping. So if you're in California, you're paying for shipping to California. What, a whole semi truck?
Aircrete is so voluminous. Gosh, it is so big. I hear you. So basically, what we're saying is it's much cheaper to make your own. And Harry's got tremendous information on his YouTube channel and in his training on all this nitty-gritty bits and pieces. And I have a video as well where we almost pray and dance to this Aircrete, so it comes out all right. So it's really like a witch's brew.
Yeah. So I just want to continue real quickly with the Aircrete.
Yeah.
So again, most important is the water for your foam solution, as well as the water going into your cement slurry, has to be soft. And as far as the soaps, now this is key. Soaps are designed for cleaning, and most soaps have a citric acid in it. And what you want to do is neutralize the acid with baking soda. You take a teaspoon of baking soda and you add it to your foam solution to help neutralize the acid. That's another thing that's causing the bubbles to collapse, is the acid in the soap. Remember, they're designed for cleaning. Now, I prefer using Drexel foaming agent, which is designed for making foam. Now, that's designed for another purpose, for pesticides and all that, for farms and things and crops. But the Drexel works the best, I found. And I had another mistake yesterday. Holy cow, giant wasp just came in here. I had another mistake. I started an experiment yesterday, right? It's two experiments. One is to show how you can make a column out of plastic. So I take regular plastic, 6 mil plastic, wrap it around a cardboard tube, 8 inches in diameter, and then I pinch it between 2 pieces of wood. And this is a really cheap way to make columns. So I made 2 12-foot tall columns, and my experiment was going to be to fill one with Aircrete made using 7th generation soap only, and the second using my ingredients, which is air entrainment and the Aircrete Harry thickening agent. This thickening agent allows you to pour much taller. So the test, I wanted to
Okay.
see how tall can I pour. So I was gonna pour 12 feet and see how much collapsing I get. So far, I've poured a maximum of 30 inches in one pour of Aircrete. And this thickening agent keeps the Aircrete right there. Wherever you pour it is where it stays. It's
That's
incredible.
amazing.
It
Just
works
for folk
amazing.
out there, remember half an hour ago, I've mentioned that we weren't able to pour anything more than 4 inches at a time. That's why our bricks are 4-inch thick. And Harry just mentioned that he pours 30 inches at one go.
Yeah.
And it stays there. And the bubbles don't collapse under their own weight.
No.
Or the weight of cement.
And it's beautiful. And the Aircrete just looks like you're ready to eat it. You know, it looks so delicious. If you're into Aircrete, it looks delicious.
Yeah. Nice. And on toxicity level, this dextral stuff, is it all right?
I don't have an issue with it. You know, anything in concentrated form can be dangerous. There are a lot of food products that, if in concentrated form, are not good for you. So we're talking about 4 ounces for 5 gallons of water. So it's really diluted a lot, you know, so, but there is a warning label on it. And I have to say, really, you know.
But is the predominant ingredient sodium lauryl sulfate? Am I correct?
That's the predominant ingredient in there.
That's it. Okay. Yeah.
For sure.
Look, if you can, and can you get just if you want, just get sodium lauryl sulfate. I know it's quite expensive, but if it just gets that, have you ever had experience with just using that?
Yeah, I actually bought some, and I have a foam comparison video from like 2 years ago or 3 years ago now, where I tested Dawn, Drexel, sodium lauryl sulfate, and another soap, and I made foam with all of them. And you know, depending where you are in the world, that might be your best option. And in this country, in the United States, I would just recommend to everybody just to use Drexel, because Drexel has outperformed Dawn and 7th generation tenfold. Like, they cannot compete to Drexel. I filled a 5-gallon bucket with foam, and I have all these experiments recorded on my YouTube channel. And you see within 2 hours, Drexel and 7th generation, the bubbles collapse. And Drexel is right at the top where I started.
Wow.
And so it's just a far superior.
So that's it. Harry's done the experiments, guys. He's done a lot of experiments. Yeah, it's great. So in each country, we weren't able to find in South Africa neither the 7th generation nor the Drexel. That's why I said I had to go to about 6-7 different soaps, because they all have different ingredients. But I didn't know about the citric acid, because I think that's what kept us for a week trying to figure it out, and it kept on dropping and flopping on us.
And there's also how much soap you use. What I found is, to get a comparable density foam out of like Dawn, I have to use the entire bottle. I can't use a few ounces. In one 5-gallon bucket, I use the entire bottle. This one's 20 ounces. I have other bottles that are 25 ounces. The entire bottle has to go in. And this is why in my test, I show that this is more expensive to use than Drexel, because I only need 4 ounces of Drexel, and I can make 160 gallons of foaming solution with 1 gallon of Drexel, opposed to using an entire 20-ounce bottle per 5 gallons. So this is why.
And you keep on speaking, Harry, you keep on speaking about the latex. Latex is something that, what I understand, has got a little stretch to it. So if you put it into a little paste, a little thin thing, and it dries out, it's something that can stretch a bit, correct?
No, not the latex.
For?
Yeah, the latex I refer to as latex bonding agent. And this is usually what's used in the mortar mix with with a lot of Aircrete domes. The outer layer has a latex milk. It looks like milk, but it's not. Don't drink it. And that's mixed with cement. So latex was designed for adhering new concrete to old concrete. So you have old concrete, you put this latex layer on there, and the new concrete will stick to it. Now you can also mix it into the cement. And I share this because I got this information from reading about this gentleman back in the 60s, George Nez. And this was his recipe of using 60% latex bonding adhesive and 40% water. So what I've done is I've just used 100% latex. So latex is made with water. So there's water in the mix already. So I replace all the water with just latex bonding agent, and I get a very strong cement layer. This is not for Aircrete though. This is for that first structural layer on the airform that I spray. I don't add latex to Aircrete. It's only for cement and sand mix. So instead of water, I make it latex, and it sets up a lot faster. That's why my system, it only take you 3 days to build a dome, maybe 4 to 5 days for like a 30-foot size dome.
Wow.
But the speed at which you could build is off the hook. You know, it's so fast because a regular sand cement mix after 6 hours is halfway to full strength. You need a full 4 weeks for any cement mix to reach maximum strength. It's 4 weeks, but after 6 hours, a regular like 3,000 PSI mix, you're already at 1,000 PSI in 6 hours. So this is why in the first day.
Are you talking about that? That was a hopper gun?
Yeah.
Or you're talking about was your blaster?
Either one. It's the same process.
With a hopper gun,
Shotcrete or with the Stucco Sprayer.
Stucco Sprayer. Is it better to have an extra person who can keep on loading you up?
That helps, but a lot of times, you know, you might not have, you know, like when I built my dome, I had my wife to help me operate the machine, but I did everything else by myself. So it would help to make it less laborious on yourself, because you do have to hold the Stucco Sprayer and all the weight of the cement in that little hopper. So you will get a workout, but you will get it done. You can get it done. Like I work quickly. Thankfully, I got some muscles on me, my vegan diet, but anybody can do it. You don't have to fill the hopper all the way. You can make it easier on yourself. Just fill it halfway so it's not so heavy, because you will have to do it maybe hundreds of times, you know, by the time you're all said and done.
You know what? I would love
really quick.
Something that comes to me. It would be really nice to have. I'm just thinking aloud, and this would be amazing for your system with a hopper gun. And I'm trying to develop a human 3D printer for Super Adobe, because the biggest, you know, the biggest challenge with Super Adobe for me is like Harry's talking about 3 days a dome is built and a couple of days a foundation is done. I've been going for 4 months on this Watellarium cold climate home, and I haven't even reached the foundation level to the ground. Super Adobe is very, very, very slow. It's mass. And for cold climate, we need it. But we're talking about 2 different systems. So if we can find ways to speed up, and the thing that I'm thinking, Harry, what if we have some form of either bamboo or some form of a structure over our dome? Let's just talk about the dome. So we build a cube first. What if over that cube there is some form of a spring that helps us hold this hopper gun, or that helps us hold the Super Adobe hopper that fills in, and it can travel it can go back like a 3D printer, but a manual one, but it's on a set of springs that we can pull it up and down, and so you can load more weight into the hopper that for example, could something like this be developed for Super Adobe and for holding a much bigger hopper gun? Or what do you think?
Yeah, I think that's completely possible, because if we look at cameras, and when cameras are filming, they usually are on a crane with a counterweight in the back. So I could see the rope coming here and you having a counterweight there to just make it easy. Yes. I could definitely see that helping people who maybe don't have the strength, maybe a little older, but they want to build their own home. I could see that working very well. And you could probably even just buy something that already exists, but you got to look in the camera world, in the camera industry for like video cameras. And it's always, you know, it's a mass on a pendulum of some sort with a counterweight.
Yeah, I love it. I love it. You're giving me,
Yeah.
so what you're saying is, so if something, again, this is, maybe you don't want to do it if you're just building one, but we're talking about, first of all, new economic opportunities. I'm seeing with Harry's method, I want to build myself 10, 15 homes that I can, for example, have students at our school, or Harry builds 10, 15 little domes that he can have students coming at his place, because right now camping is not for everybody. So we want to look at, you know, certain fast, rapid growth. So these methods that Harry and I are discussing can help you build. Once you figure out one, and that's why it's taking so long for Harry to figure out this one, and for me to, but the idea is you can then replicate, correct?
Yeah.
So I could have a 200 or like 100-gallon drum on this system that you're talking about. And from that drum, I have like a chute that helps me, that I can, with an open, a release, and release 1 bucket of super adobe mix, boom, into my bag, and then I carry on.
Yeah, but again, this is all experimental, so you have to be careful if you want to try this yourself. Like when I talk, like we're freely talking ideas, you know, off the top of our heads here. But, you know, normally I would try something myself before I would recommend anybody doing. Like recently, I don't know if you've seen my last video, Alosha, I came up with a DIY Aircrete pump. And it's so simple, using a 50-gallon drum with a 2-inch opening and a 3/4-inch opening. It just works so beautifully. And before we get too far away from the subject, I want to share my screen and just show people real quickly my the stucco spraying. And then I want to show you my idea for making what I call work smart, not hard, right? And my idea for a super adobe structure. And so I'm going to share my screen and show you the first is going to be the video of the stucco spray in action. So here you can see, this is, oh, okay, I went too fast. So that's the stucco sprayer, and that's spraying a cement mix onto the airform. Can you see that, Alosha?
Yeah, very well.
And here's the second airform going over the first shell. So that first one's concrete, and now we're applying the second one, and here's the fiberglass mesh. And so we're putting the mesh over. This is the workshop. These were everyone who came to the workshop. See, so that goes over. So this is my reinforcement layer, as well as my first layer the cement will grab onto. And I'll just skip it. And you can see it's now fully inflated and tight. And here's the stucco spray in action again. And so it's not difficult to do. You know, we have women, men, all different sizes and strength and capabilities. And you can see it goes really quick and smooth. And that's the first layer. And here, this is my, if you look here, that's the drum I'm using to pump Aircrete. And so anyway, that works really good too.
So I didn't get from your video, so this is a final result. So basically you pushing the air through the 3/4 inch per entrance, and then you have a 2-inch, and that's where you load what?
The Aircrete gets loaded into there. See, I'll fast forward.
Is this, are you talking about you reinvented an Aircrete pump? Because you have this, or
so you see in the back.
Usually you have this white little contraption that you sell on your site, correct?
Well, yeah, that's the foam generator for generating foam.
This is not the foam generator.
No, this is a DIY Aircrete pump anybody can make with one of these 50-gallon drums or 55-gallon drums. And you
So
see here,
with this drum takes a foam inside and cement, correct?
right, I already mixed, I fast forwarded. I mixed the Aircrete already, and then I transferred the Aircrete into this drum, and this is the hose that's going to pump the Aircrete up into the top of the dome to fill my 6-inch cavity.
Got it.
See, and we use air pressure. It's so simple, so easy. And if you have to get Aircrete up high, or maybe you're filling forms and you don't want to have to move and carry tons of buckets to the forms, from one location,
that's a
you can
big
mix.
problem all the time. Those buckets are heavy.
Yeah, and it works so quick. Like, it's amazing how good and simple it works.
How did you get Aircrete inside a big drum through such a big small opening? Was that the little funnel is for?
Yeah, that's the funnel. Let me see. Do I show that? So I show mixing.
Yeah. There was a funnel, but you.
Oh, here. Okay. So here I'm filling it with Aircrete.
Okay.
The Aircrete's already mixed.
Got it.
Because if I didn't make this, I would have had to use a diaphragm pump I have that works. But my intent here was to show people how to do it on a budget. You know, how to do it as inexpensively as possible.
That's incredible.
This particular method. And then, you know, we put the air pressure on and it pumps it right in. And it works beautifully.
That's awesome. Thank you for sharing it with us. Yeah, man. Yeah, I've also been playing with a little invention with Super Adobe. Whilst you speak, I'll try and. I wanted to share actually this picture because I promised everybody that was the. Can you see this wetland?
Yeah.
So this is all these complex pipes. And this is what I did. I filled it with water first. Excuse my jacket from previous days. But yeah, so all these pipes floated. And that was the problem. All these fittings and joints came apart. And it was a real mess. It was the most expensive mistake I made. The other most expensive mistake I made is I bought this EPDM liner for my other wetland in a circle. In a geodesic dome, in a large 33 foot geodesic dome. And this liner I've cut too short. It was still 4 inches above the water level. But what I didn't know is when you start pumping water, the water backs up through the gravel. It doesn't, gravel has resistance.
Right. It's
not like big boulders. The water backs up and it just started overflowing. And that liner was $5,000. Oh, and I've cut it too short so quickly. Yeah, it was, that wasn't a very expensive mistake.
Yeah, that's painful.
So, yeah.
So I'm going to share one more thing with you. This is my idea for an Adobe structure. So the idea here, let me see if I can open this up. Do you see this screen, the eBay? Okay, these are super sack bags. These bags are able to hold 2 tons of weight. They're 36 inches by 36 inches by 41 inches.
Yeah, they deliver sand in them. They are the Super Adobe bags, but they're really strong with handles. They're
really big and strong. You see here, there's a forklift picking one up that's empty.
I can't see that screen, Harry. I can see the screen with your Rhino.
Oh, okay.
sharing.
Hold on. Let me.
So you need to click stop sharing and then start sharing again and then choose another screen.
Okay. So here.
Yeah. Okay.
So you can see you get 220 bags that are good for 2 tons each. And the size is 36 by 36 by 41 inches tall. And here you can see it with a forklift picking it up by the handles. And so now I'm going to stop this screen. And this is on eBay. And this is an experimental method I would like to try. Uh-oh. My battery.
Oh, man. It would be so nice for us to collaborate and have maybe like a whole...
Alosha, give me 1 second. just talk. I'll be right back.
Okay. I'd like to share, whilst Harry's gone, a method that I've developed to build super adobe by myself. It's just a little slide. I am putting a whole course together, so this is what I'm building with, you know, on the land here, right next to me. So basically, I've got I've made this like replacement. So I feed it myself, and then I jiggle it. Yeah. Basically, it's a method to build a super adobe by yourself, but it still takes a long time, you know.
Okay, I'm back. I had to run and get the
Did you
power
see
cord.
that?
Yeah, I actually I saw that in your video for Brazil.
Yeah.
Catch my breath. All right, so this was the other thing I wanted to show you. Now, the super sack bag idea is for this structure here. These would be the super sack bags. I'm still catching breath. And so the idea is you would build 2 levels. You would have radiant tubing going all the way around on 2 levels, on the bottom and on the second level, so that you could pump hot water through there. And you would have this massive thermal battery, 35 inches thick of soil.
Wow.
And then on top, well, once completed, this would then get a mesh to cover it. And then on the outside and the inside, I would spray the Epic mix, which is expanded polystyrene, paper infused cement. So it's styrofoam, paper, and cement. Now,
wow.
I like that mix a lot because it's really strong and insulative. And if you're spraying the inside, you'll have walls that you can screw things to. You'll be able to use regular wood screws and, you know, make your walls nice and smooth, and you'll be able to screw into it. And then for the outside, I would just make it as a finishing layer on the very outside. And then the idea is I'd build a dome on top, but you have all this thermal mass here that'll be very strong, but this system would involve a piece of heavy equipment. Now, either an excavator or like a bobcat, one of those two.
You know what, Harry, I'm all there. Just to chime in there, guys, a bulldozer driver never came to help me in the beginning of the season to remove the turf, the grass, and it's, you know, in our areas like very thick, and the roots. It took Zoya and myself 30 days of everyday work to remove what a bulldozer could have done in 2 hours. This is the power of machinery. There is nothing wrong with burning a little bit of fuel that you could save yourself 95% of the time, and then let this machine go. Like in permaculture, they'll use an excavator, but then you have yourself a pond with a whole ecosystem for the next thousands of years that's going to have all the future generations benefiting from the, you know, an excavator did just a couple of days. So don't be afraid of machinery. What Harry's talking about, to build a wall like that with hands is going to take you a year with a shovel and spade. A machine like that can do that in probably half a day, correct?
I'm estimating it would probably take 1 to 2 days to fill these bags with an excavator and move them into position with the excavator. I think 2 days, and you would have a thermal mass wall that is super safe, you know, very efficient as far as, you know, this is almost the equivalent to digging a hole in the ground and building a basement with walls this thick.
I love it. I love it.
And this is, for me, is all about working smart and not hard, and also working fast. So you figure it would take you about 2 days to fill these and stack these super sack bags. And then, you know, another week to finish your dome. This is a 30-footer. And so you can easily, once you fill the bags, you put a header, just like Earthship does. They put their tire wall and then they put a concrete header on top before they rest their
A
beams.
beam, a concrete beam.
Yeah. So you make your concrete beam, you mount your airform, inflate it, and it'll take you 3 days to spray the airform because you have to do it in layers. You know, you can't do it all at once. You want to take your time. That's funny, right? Take your
And
time.
also
It takes 3 days.
What I like about these thick bags is they're nice. They're going to be nice to work on, because if you make anything thinner, you can't actually step up to work safely to spray this dome. And this would be a nice little space to work on.
Yeah, absolutely. So anyway, this is my idea for an Adobe. I was hoping to do a workshop maybe in Arizona where they have the soil conditions for this, you know, but it has to be like, I couldn't do it here. I don't have the soil conditions for this idea. But you saw the prices for 800 something bucks. You have probably enough bags to do 2 domes, you know, of that size. I didn't count how many bags, but it's
and
not
Harry,
that
why
many.
do you say you don't have the right soil? What type of soil do you need to have on this? Sandy, of course.
Yeah, sandy soil would be preferred, that you could easily scoop up, or you can, you know, use either the blade on the excavator or a bobcat to scoop the soil up and put it in. Now,
Okay, and what type of soil do you have?
I have clay rock soil, very clay and rock, very hard to dig. Like, I wouldn't even think about digging my soil by hand. It's just so difficult. And yeah, I don't have the soil condition, but someplace like Arizona or New Mexico, like when they build those earth ships, they have the perfect soil to fill that. You could scoop the soil up from your local area and then fill the bags. And
yeah,
for me,
for example, you could dig a hole where you could create a root cellar or a pond possibly, and use that soil up into the bags. So you actually, in permaculture, we always stack functions. You make one thing, but you actually kill 2 birds with this as 1 stone, as you know, they say.
Yeah, absolutely. And so I would also mix cement in mine, maybe a 1/4 bag of cement per bag, just because I like to overkill. I like to overdo it, make it super strong, but I don't even think it's necessary at all, because you'd have
as long as you
4,000 pounds of sand.
As long as you plaster your bags from the outside, there is no need for, and the other condition, sorry, as long as you plaster the bags from outside so they don't deteriorate. And second condition is, as long as you have a gravel foundation where the water can't wick up, or the bags are lined with plastic from at the bottom, maybe you put a sheet of plastic, you know, staple it up or something, so the water can't wick up, because especially fine sand, it has a tendency to siphon, or what's the word?
You got it. Siphon and wick. Wick is the main thing. Even in concrete foundations, concrete will wick moisture up as well. So this is why, like in my foundation system, the ring beam that's concrete is covered in Tyvek and plastic. So it completely avoids any wicking of moisture into the house.
Yeah. So I think for this session, I think we should come to a wrap. But in the next session, I would like, and we can do this weekly. With, you know, I'm happy, because there's a couple of things I want to discuss in the next, something for you to think about. I want to go, how do we get around codes with our plumbing, and some of the ideas I'd like to discuss in the next session. So sizes of our buildings, and interesting plumbing techniques, compost toilets, where our homes are not registered as buildings. They are growing tunnels that you can sleep in, and there is no plumbing as such, because Well, I have a waterfall that I can just turn this hidden knob and suddenly my waterfall becomes hot, you know, and then I stand on a gravel bed that's a wetland, and then that water, for example, treats and goes through a biochar filter and comes back over the same waterfall. It's always a looping system. So I am designing, I want to think of ways and brainstorm, Harry, with you, and maybe other folk can also give us ideas, because I know in US and Canada and UK, the governments are really strict with the codes. So for folk like us who want to build homes, not just experimental, but actually have a home that we can live in and not camp on our land, you know, how do we go around codes? And that's something I'd like to discuss with you in the next session.
Yeah, that
So
sounds like fun. But I think on this session, we should throw out that you're going to be in Brazil next month for your workshop. So why don't you briefly, before we hang up, tell us about the Brazil workshop that's coming up, because it looks really exciting. It looks like you found a beautiful location to start a community. I don't know the gentleman's name, but I have people messaging me on my video, like, where's the location? But it looks absolutely beautiful.
Oh man, yeah, Harry, we've got a workshop happening on the 5th of this is a Portuguese version. Can you see this graphic?
Yeah, I see it.
So basically, this is what I'm doing. I've got this Aircrete dome here, little bubble, dome Gaia style. I've got a little walk-in spiral shower that you can walk in right there. I've got a vault, which is again taken from Cal Earth. I've just basically combined it with sacred geometry, all of this. Buckminster Fuller's geodesic dome. We've got a wetland from Mike Reynolds. So, you know, these are systems that work. And then I've designed my own little ferro cement or bamboo structure. And then on the back, we've got a little super adobe dome. In fact, I've got it loaded in my Rhinoceros program. Let's see if, okay. Share screen. Yeah, there it is. I know. So basically, we're going to be building a few methods. These methods are a combination of what I've been doing actually for many years. I've been developing this home for, in fact, these are some of the different designs. Can you see all those different designs?
Yep, they popped up.
Yeah, so basically, I've just, like Harry's obsession is Aircrete, my obsession is how do we design buildings that can be done DIY style without climbing into debt? And staying in South Africa for 25 years, and I'll show you what I've built before, and maybe you've seen on my YouTube channel, but basically I'm combining a few methodologies: Aircrete, Super Adobe, Mike Reynolds Earthship system, greenhouses that not just dump heat like they do in Taos, but actually take the heat from the greenhouse and channel it into the back berm. So heating up this back berm cushion like the Earthship, but actually really heating it up. And then throughout winter to get to use that heat back in the house. So this is my cold version that I'm doing for really cold climates. And this is my masterpiece, I could say. So the request came in with a confirmed confirmation for a warm climate. So I quickly made an adaptation. You know, that's why there is a little hat that came through for the geodesic dome to basically stop the sunlight from coming in, a roof which will also have solar panels on it for Super Adobe, again to shade it through. And of course, it doesn't have to be all buried up because you want to have good ventilation and so on. So basically adapting to various climate zones. And in this case, a humid, tropical, hot climate. So just showing you how natural building can be tweaked knowing different methodologies and how studying basically what nature does. So another feature I'd like to add in this Brazilian workshop is a tall chute to pull air like an anthill does. So it can really, like an earthship, it gets that metal tube through the shady side to geothermal cool air to pull into the house. To create a pool, you want to create suction. So one way to achieve it is to open your skylight in your greenhouse. Another way is to have a solar chimney, which is basically a black pipe, about 6 inches diameter, with a reflector on the back, like your torch, and a polycarbonate on the front, and with the black pipe in the center. So the polycarbonate is going to create this, basically stop away the heat from escaping, and the sunlight comes in. The reflector is going to get that black pipe so hot, and hot black pipe, 18 feet tall, will create a hell of a suction. Pulling air from where? Underground air that's natural, the earth cooled down naturally. So my obsession is to create these passive homes, solar or not. The home that I'm developing for Russia is got nothing to do with sun. We have 4 months of no sun. So that's why these are the solar tubes that I'm talking about for summertime. But in wintertime, when there is no sun, I have a reactor here, which basically has compost, which has wood chips and human manure. I'm designing it for Mars. And human manure is a safe way. Obviously, there's not going to be any smell, but we're basically going to pump human manure with a macerator pump that's going to fill that cavity between the sauna, the super adobe sauna, and the Aircrete blocks. These are thick Aircrete blocks, Harry style. And basically, this space is going to be filled with wood chips and human manure, or wherever you can find any carbon material, such as grass clippings, which is in abundance everywhere, straw bales, which is in abundance everywhere, any source of browny stuff with nitrogen, which is human manure or green leaves. So basically, that's going to create extra heat for those times of the month that we, don't have any sun. And so I've just adapted it for Brazil, and I'm inviting you guys to come on the 5th of November, and we're going to build a vault, an Aircrete dome, and super adobe dome. And if we have time, we'll do that bamboo structure on the side and the wetland. But those 3 structures, if we get 10 people, we can pull it off. So I invite you. Thanks, Harry. Yeah, that'll be great. And we are going to be doing something with Harry. It's just a matter of the borders opening and me being able to fly. But I'm really envisioning us doing a little research lab. Basically, what I'm doing, what Harry's doing, just combine it together and do a continuous space where people can come for part of the year and actually collaborate in the research, because that's what really is needed. And Harry can chime in on that, but hands on deck are needed. It's nothing can be more daunting than, like, I've built for 3 months alone in this summer. It wasn't a nice experience. Although it was good time to research and be with my thoughts, we are social beings. We want to play together. So I see a collaborative lab, experimental research space, training space, call it whatever you want, but it's a space where people get together and play. And this is what I want to build. This is my dream. I want to build it in Brazil. I wanted to build it with Carrie in Colorado. I want to build one in Russia. And I was spending 12 years in South Africa building this conglomeration, but I gave it to the bank because it was on the bank's land. That's why we're talking with Harry, natural building methods without debt.
Yeah, that's the most important thing. If you can do it with a small budget and build something that's going to be strong, because even now, like just in this country, I'm not sure about the rest of the world, but there are many natural fires that are happening. There are floods that are happening. People's homes, their property are being destroyed because they have these traditional style homes. Even certain areas have tornadoes. So these structures we're showing, Alosha showing, and I'm talking about, they're very
They're
strong.
fireproof. They're
They're
fireproof.
completely
Yeah.
fireproof. Your home will
In
always
fact,
be
they get
there.
stronger with fire, correct?
Some of them do. Some of them, the
Yeah,
fire just cures, like the Adobe stuff just gets definitely stronger.
yeah, yeah.
So, you know, but the most
So,
important thing is that it's affordable. So, Alosha and I
yeah,
were definitely like-minded. You know, I also wanted to get another piece of property out in Colorado that's easy for people to access, opposed to where I am, you have to fly, drive 3 or 4 hours, depending where you go. So I was thinking another property somewhere that's closer, that's easy access for anybody, because really the hands-on is key. Like you can learn from videos, but when you're there and you have me or Alosha over your shoulder saying, no, do it like this, and this is going to save you time, this is going to save you injury. You know, being injured is also what you want to avoid. And I talk about that all the time, wearing proper safety equipment, always safety glasses and a back brace if you're lifting heavy things. You want to be safe. You don't want to try and build your house and hurt yourself. It's not worth it, especially if you're
yeah,
older
yeah,
and you
yeah.
have these issues. So these hands-on workshops are really key to really learning, getting a feel for it all. And I always recommend all my students who come here, I say, as soon as you go, just build a small dome. Quickly get
Yeah.
right to it so you can remember everything and put it into practice yourself. And so that's a really key thing, is the
Yeah,
hands-on,
I'd like to.
doing something
I'd like to just.
immediately.
I'd like to just, as Harry was saying, when I went to Flying Concrete in Mexico, this is exactly what Harry said. Can you see this little hut?
Yep.
As soon as I got back from Mexico, I thought, yeah, I've got a little corner, and I chafed away the paint, got to the brick level, drilled some holes to put a rebar in, yeah, and then put some mesh, and I made myself a little dog hut, or call it a washing machine space, whatever. This was the first project I tested. The next project I tested was immediately going to a ferro cement roof. Can you see this picture?
Yep.
I would have never been confident to go straight away for this project. But as soon as I did that first project, it's one thing seeing it done, but another thing actually getting by yourself and building it. Because and that's why Harry's saying build a small thing first. Because once you have experience with a small thing, then you will be so confident to build any size you want. But you've got to start small.
It could feel very overwhelming to go, you learn something, and then you're going to build like a 20-footer. It could feel very overwhelming. And again, you do a small one, you get your confidence. You don't, if you make any mistakes, if they're small mistakes, small cost, it's not going to be an expensive mistake. And that's the best way.
Yeah. My first my first structure was a 7-foot super adobe dome that I learned from the book, Nader Khalili's book called Emergency Shelter. Highly recommended book. So I looked at the book, I said, okay, I can do this. And I've made one window and one entrance just to try out the methods. I didn't get the window geometry right, because when you got, you still have to continue with the egg shape, you know, the Lancet art geometry. Even if you've got entrances and openings, doesn't matter. I didn't get it right. My whole ceiling started collapsing. I started seeing it slowly move, and I had to prop a pole in the dome for that not to fall down. And that pole stayed there forever. And thanks God I did that on a small building. And then I ramped up on then I went to Cal Earth and did the whole course. And then I did 3 domes connected to one central dome. And I made the biggest mistake. I've got a video called Plaster Disaster. And that mistake was I did not do test patches. I made this natural mix with my own clay, like similar, like carrier soil. It's very clay, but clay shrinks. And I didn't do a test patch. you're supposed to do like a 2 foot by 2 foot test patch where you try your plaster mix here, then you put some more sand, you try a little patch here, you put less sand, more lime, and you write it all down and you try a test patch there. I didn't. I got one mix. It felt nice with my hands, and we plastered the whole thing inside and outside. And watch my video, Plaster Disaster, because the first thing that happened is we started having, and on the outside, after that, we did the whole Cal Earth, do little squares that you, of the super adobe, and then dip it in not rubber, but bitumen type of black tarry stuff, yeah?
Okay.
Natural. And you dip the squares and you put it like a pineapple and you wrap it. And then you whole dome, you wrap it, and that's a really good waterproofing. Then you throw sand in it as it's still wet, and the sand gets stuck into this bitumen stuff, and then you plaster, and that gives you like a plaster key for your final plaster. We did all of that. And then 2 weeks later, as the moisture started escaping, the inside of our house started getting cracks. Then we started getting bigger cracks. Then I immediately made this tool with lots of nails, and I started poking it all so I could get the air fast enough out. It didn't help. All of the plaster fell down on the inside, all of it. And it was a dome with 3 domes connected to it. And let me see, disaster. And the next thing, the outer layer was all those little squares and outer plaster also started collapsing, and I started happening, basically it was a mess. My entire plaster just collapsed, and here we go. There's a lovely picture. Yeah, so this is what happened. So this is when it finished, and we're like, oh my, on the right, this is so cool. And the next thing, the inside plaster fell away, and the outside plaster, this is what happened. It all collapsed as well. This is the cement. This is those squares, the black bitumen stuff, and this clay stuff that shrank. So this beautiful dome turned into this plaster disaster just because I didn't do the test patches.
Right.
So mistakes were crucial. I mean, expensive, and when you're on your last cash on your land, and this thing happens, and all your plaster falls away, I sat down, I burst into tears, and with my last $100, I booked a ticket back to the city to go and do work, because that was it. So these mistakes can really, they can actually alter the direction of your life, because you can get to your land and you think, right, I'm going to do this, and you have your budget and tightly planned until the completion of your building, and then you can, with your family, move into this home, and all your plaster collapses, and it was expensive, and you relocate back to the city to go make money. So this is how my mistake turned out for me.
So that's why it's important to do a small structure. And it doesn't have to be something you live in. It could be a shed where you store things, or you can make a gazebo that you'll use, but do something small, get the practice, learn how to mix, because maybe you put too much water in your cement or not enough water. All these things you can figure it all out with a small structure. My very first structure in New York, in the backyard in Staten Island, was an 8-foot diameter dome where I was testing my concept out. I was testing the whole idea, and you can see that in my videos. If you go to my first videos for Aircrete New York, I showed the whole process, what I was doing, and I did a small experiment. And then after that, and that small experiment was like about $2,500. After I did the experiment and I felt comfortable, I then invested tens of thousands of dollars on airforms that I bought and I never used, because these airforms are so incredibly heavy, hundreds of pounds. And I'm trying to do these builds myself. That's why I ended up coming up with the Tyvek airforms and a low pressure system. But most important, just do a small experiment first. Don't think too grand at first if you've never done it before. Very key tip. Important tip.
And support myself and Harry through PayPal. We'll put our links below, or purchase one of our courses, because all the money goes towards R&D. Really, all of it goes
Yeah.
towards R&D. And we share all our mistakes freely with folk, that so you guys don't have to repeat the same costly bumps. So your support really makes us, I don't have any other income except, our natural building. Do you, Harry?
All I have is the little bit I get from YouTube, which is maybe 100 or 200 a month, and my foam generators.
Exactly. Yeah, exactly. So your support is necessary. Thank you, guys.
Yeah.
Thank you, Harry.
Thank you.
Awesome. Awesome. So you can stop recording now, and
Okay.
then you can just